the way I transferred power without wires was through the use of two Tesla coils. This Tesla coil was the transmitter Tesla coil, and this Tesla coil was the receiver Tesla coil. So power from this was transmitted to this, where I was able to read the amperage and the voltage and then calculate the power. So power from the outlet was taken into this Tesla coil, and it was about 720 watts worth of power. Now this is, it works on the same principle as a radio, where if you have two oscillating circuits, if they work in the same way, they'll be able to pick up each other's frequencies. In the same manner, instead of doing with radio frequency, we're dealing with oscillating electromagnetic fields. So this is generating an oscillating electromagnetic field, and because this coil is designed in the exact same way as this one, the same number of windings in the secondary coil and the same number of windings in the primary coil and the same geometry in the toroid, because that is the case, it will be able to translate the oscillating electromagnetic field into current. So what it does is it takes the electromagnetic field in the air and takes that and it works in the exact opposite manner as that transmitting coil. So as this coil is taking high current, low voltage electricity and transferring it to very high voltage, very low current electricity, this coil takes that high current, high voltage, low current electricity, and through the secondary coil and the primary coil gets it back to a lower voltage and a higher current. That electricity is sent through these wires down to another neon sign transformer. Now, unlike that neon sign transformer, this neon sign transformer is working in the opposite direction. This one, over here on the transmitting one, was a step-up transformer. It took the 120 volts from the outlet, stepped it up to 12,000 volts. This one is taking the high voltage translated from the air, and it translated it back into low voltage. So the way I measured it was I measured it from the low voltage electrodes on the transformer. So what we did was we turned on the transmitting Tesla coil, and then very safely, with the use of a very thick glove, we took this electrode, which you can see I am no danger of getting any type of current from this because I'm separated by an insulator. I brought it near, and then through the use of pliers I connected it to this electrode, and then I connected this electrode. I connected the leads to those electrodes. And then that was connected to the multimeter, and first I measured the voltage, and I had it run for about 15 seconds and recorded the highest voltage I saw and the lowest voltage I saw. And then we turned it off, and then I switched it to amperage and measured the amount of current coming out of the transformer. From these values, I was able to get the amount of power, and thus able to see the amount of the ratio to the amount of power put in, 720 watts, and the amount of power put out, which was on the order of 7 to 16 watts. And that is how I measured the wireless transmission of energy.